You ever notice how AI seems to have this weird split personality? One minute, it's writing a poem that could make a grown person weep, and the next, it's failing a logic puzzle a 5-year-old could solve. This wild gap between genius and, well, not so genius, it creates this powerful illusion that the AI is actually thinking. Today, we're going to pull back that curtain. So let's just get right into it. The big question we're tackling is this: is AI just faking it? Is this all an incredibly sophisticated magic trick, or is there some real thought going on in there? To really get our heads around this, we have to start with a classic thought experiment. And that experiment is the Chinese room. Okay, picture this. You're in a locked room. You don't speak a lick of Chinese. Someone slides a piece of paper with Chinese characters under the door. Now you have this giant rule book that says, if you see this symbol, write down that symbol. You follow the rules, slide the paper back, and to the person outside, you're a fluent Chinese speaker. But you, inside the room, you have zero understanding. You're just matching symbols. The latest research suggests that our AIs are basically that room, just scaled up to a global level. So, how did we end up here? Well, for a long, long time, the entire AI industry was basically obsessed with one single idea. That idea was called the scaling hypothesis, and the belief was pretty simple. If we just make the models bigger, throw more data at them, give them more power, then true human-like reasoning would just kind of pop into existence. The industry bet billions that scale was all you needed to get to genuine intelligence. But was that actually true? Well, the first big cracks in that whole belief system started showing up thanks to some bombshell research from, of all places, Apple. They decided to do something different. They stopped cheering for what AI gets right and started digging into how and why it breaks. And their approach was, frankly, brilliant. See, instead of giving the AI the same old tests it's probably already seen a million times on the internet, they created new dynamic problems. They wanted to find out if the AI was actually thinking its way to an answer or just recognizing a pattern it had already memorized. This is the perfect example of what they did. Take a look. On the left, you've got a simple math problem, right? 44 plus 58. Easy. Now on the right, they added one tiny, completely irrelevant detail. 5 of them were smaller than average. Any human knows the size of the QEs doesn't matter. You just ignore it. But what do you think the AI did? It was a complete disaster. A lot of the top models saw the number 5 and just couldn't help themselves. They felt this statistical pull to use it, usually by subtracting it from the total. And we're not talking about a small mistake here. For some of these AIs, their accuracy just fell off a cliff, a 65% drop. Now, check this out. This wasn't just a problem with one bad model. Look at these numbers. Even OpenAI's fanciest model took a nearly 18% hit to its accuracy. What this proved was a really fundamental weakness. These models are terrible at telling the difference between what matters and what's just noise. Okay, so we know the AI gets distracted easily, but what about pure step-by-step logic? For that, the Apple researchers used a classic AI test called BloxWorld. The goal is pretty simple. You have a robot arm, and you have to tell it how to stack blocks in a certain order. And the results here were just as eye-opening. For short plans, under 10 steps, the models were great. This is the stuff you see in those flashy tech demos. But the second the plan got more complex, like 20 steps or more, their performance just completely collapsed. I'm talking accuracy dropping to almost 0. The AIs would forget what they were doing, try to move blocks that were buried under other blocks, basically just making up moves that violated the rules of their own world. So we've seen the evidence. AI reasoning is brittle. It shatters when you throw in a little noise, and it falls apart when you add complexity. But the big question is, why? To get that answer, we're going to turn to a diagnosis from AI legend Andrej Karpathy, who uses human psychology to explain what's going on inside the AI's mind. The whole idea is based on something called dual process theory. It was made famous by Daniel Kahneman, and it basically says our brains have 2 different gears, 2 different ways of thinking. And this right here, this slide is the whole ballgame. System 1 is your fast, gut-feeling, automatic thinking. It's pure pattern matching. It's the part of your brain that knows what comes after a peanut butter end. You don't even have to think about it. System 2, that's your slow, deliberate, logical brain. It's the heavy machinery you fire up to solve a math problem like 17 times 24. Now here's the big reveal from Karpathy. Today's large language models are 100% System 1. They are amazing, super fast intuition machines, but they are completely missing that System 2 layer for careful logical reasoning. Karpathy nailed it with this analogy. An LLM is like a world-class improv comedian. It's creative, it's fast, it's brilliant at just riffing on things it's seen before. But we keep handing it a spreadsheet and asking it to do our taxes, a job that needs precision and logic and double-checking your work. That total mismatch is why we see all these bizarre failures. So if the models themselves are fundamentally just these fast, intuitive engines, are they basically useless for serious reasoning? Not at all, according to another giant in AI, Andrew Ng. He argues we're just using them completely wrong. His whole philosophy is this: we need to stop trying to force the model itself to be a perfect reasoner. That's a lost cause. Instead, we should be building smarter systems that use the model as one piece of the puzzle, wrapping it in other tools that make up for its weaknesses. And this is what that actually looks like. It's called an agentic workflow, and it's basically a loop. First, in step 1, you let the AI do its thing. Come up with a fast, intuitive first draft of an answer. But then, and this is the crucial part, in step 2, you make it use a tool for the stuff it's bad at. Don't ask it to do math in its head. Ask it to read a little piece of code that uses a calculator. And finally, in step 3, you actually prompt the AI to look at its own answer and check for mistakes. You create a little feedback loop. This table just lays it out perfectly. The standard way we use LLMs is like a single, fragile gas. But this agentic workflow uses loops and tools to build a much stronger, more reliable answer. What we're really doing here is engineering a kind of synthetic System 2 to go along with the model's natural System 1 brain. So what this all really means is that we need a pretty big shift in how we think about AI. We've got to move away from this idea that it's some kind of magical thinking machine and start treating it for what it is, an incredibly powerful but also flawed tool that requires a very methodical approach. So let's just boil it all down to the 3 most important things to take away from this. Number 1, LLMs are pure System 1. They're intuition machines, not logic machines. Number 2, because of that, their ability to reason is super fragile. And number 3, the real fix isn't just making bigger models, it's about building smarter architecture around the models we already have. Which leaves us with maybe the single best way to think about using AI today. Treat it like a brilliant but drunk intern. It is shockingly fast, it's incredibly creative, and it can come up with some amazing stuff. But it's also going to make some very confident, very wrong, and very silly mistakes. So for your own sanity, you absolutely positively have to check its work.